Okay, almost done with our graphing here, but let's throw some transformations in here as well in example 5. So example 5, we're going to graph y equals the log base 2 of x minus 3 plus 4. And compare that to our parent function. Well, first of all, let's think about what our parent function would be. Well, we have our transformations, and our transformations are affecting y equals the log base 2 of x. So I'm going to add that in parentheses here. Compared to the parent function, y equals log base 2 of x. Okay. Now minus 3 is the transformation, the plus 4 is the transformation. Well, when we go to graph this, let's think of what our graph for y equals log base 2 of x would look like, and then transform from there. Y equals log base 2 of x. Think of what this means in exponential form. 2 is my base for the log. 2 to the y power equals x. Let's make my table of values. And again, it's a lot easier to pick our y values here than our x values. So -2, -1, 0, 1, and 2 again for y. And let's think about what x would be. The 2 to the -2nd power is 1/4. 2 to the -1st power is 1/2. 2 to the 0 power, 2 to the 1st, and 2 to the 2nd. Okay, and then we can change our values from here. This -3 inside our parentheses, think about what that's going to do. It's inside, so it moves our graph right 3. And if we're moving right 3, I need to add 3 to each of my x values. This is 3 3/4, 3 1/2, 4, 5, and 7. That plus 4 at the end, that's translating our graph up. Which of x are y values? Add 4 to each of them. And then we can plot these points. Okay, 3 3/4, 2. 3 1/4. Sorry. 3 1/4, 2. 3 1/2, 3. 4 4. 5 5. 7 6. And think about here where our asymptote's going to be. So for log functions, our asymptote's normally at the y-axis. But if we're translating right 3, our asymptote, I'll draw that in here with a dotted line, is going to be at x equals 3. Okay. So we connect our dots, and our function is going to look like this. And as far as our comparison goes, our function was translated right 3, and up.